Anyone who's ever programmed in C has probably wrestled with one of its most powerful, yet kind of tricky features, handling text. Yep, we're talking about C strings. So today, we're going to open up the Programmer's Toolkit and demystify them once and for all.
So let's get right to the big question, the one everyone asks first. If you're coming from a language like Python or Java, you're just used to a string type that works, no questions asked. The thing is, C is different. It operates at a much lower level, which gives you way more control, but it also means you handle things a bit more, well, manually.
And this right here, this just says it all. In Python, making a string feels like magic. It's simple, it's abstract, it just happens. But in C, you can practically see the gears turning. You're not just creating a string, you're actually building an array of characters, piece by piece. And that's the key idea you gotta hang on to.
So what exactly is a C string then? It's really simple, just an array of characters. But it has one critical, non-negotiable rule. It absolutely must end with a special null terminator, that 0 you see there. You can think of it like the period at the end of a sentence. Without that little guy, C has no idea where the string is supposed to stop, and it'll just keep on reading into random memory. Trust me, that's a recipe for disaster.
Okay, I know what you're thinking. This sounds like a huge pain, right? And yeah, managing character arrays by hand could be a lot of work. But here's the good news. You don't have to build everything from the ground up. C gives us this amazing set of tools, all neatly packed into the string.h header file.
And that's really what this is all about. Why on earth would you reinvent the wheel when there's a super robust, highly optimized, and battle-tested toolkit just sitting there waiting for you? That's what string.h is. It's got the functions you need for pretty much anything you'd want to do with a string.
And I mean it when I say there is a tool for every job. You need to figure out how long a string is? Check. You need to copy it? Or maybe stable two strings together? Yep, there are functions for that. Compare them. Find a specific letter or word inside. You bet. So let's crack this thing open and look at the essentials. All right, let's dive into the toolbox and check out the core functions you're going to find yourself using over and over again. We'll break them down by what they actually do.
First up, every good toolkit needs a tape measure, right? Well, in C, that's string length. It's as simple as it looks. You give it a string, like hello, and it tells you how long it is. In this case, 5. Now, the crucial thing here is that it doesn't count that invisible null character at the end. Super simple, super essential. You'll use this one all the time.
Next, we've got what I like to call our document handling tools. Think of strcpy as your photocopier. It just makes an exact duplicate of a string. And then you've got strcat, which is basically a stapler. It takes one string and appends it to the end of another, joining them together.
So, how do you check if two strings are identical? Now, you might be tempted to just use the double equal sign, but nope, that is not going to work in C. For that, you need the proper comparison tool, stmkrp. And listen up, because here's the one detail that trips up so many beginners. stmkrp returns 0 if the strings are the same. I know it feels backwards, but it's absolutely vital to remember. For stmkrp, 0 means you've got a match.
And finally, let's look at how we find stuff. If you're looking for just one single character, kind of like a needle in a haystack, your tool is strchr. But if you need to find a whole word inside a sentence, an entire substring, then you're going to want strstr. These two are your go-tos for digging through text. Okay, so we've seen how awesome and powerful this toolkit is, but now we have to have a serious talk. We need to talk about safety. Because with C, all that power to control memory directly comes with a massive responsibility to get it right. It sounds like a total cliche, I know, but with great power comes great responsibility is basically the #1 rule of C programming. Functions like strcpy and strcat, they trust you completely. They just assume you know what you're doing. They assume you've made enough space for the new string. And if you're wrong, well, the consequences can be pretty severe. And the single biggest risk, the one you hear about all the time, is the dreaded buffer overflow. This isn't just a simple bug. It's one of the most classic and dangerous security problems in the history of software. The concept is simple, though. You're trying to pour a gallon of water into a pint-sized glass. It's going to spill everywhere. And this is exactly how it happens, step by step. In step 1, we create a nice little box in memory, a buffer that can hold just a few characters. Then, in step 2, we grab a function like strcpy and we try to cram this huge string into our tiny box. Because strcpy doesn't check the size, it just keeps writing. And you get to step 3, the overflow. The data spills out of the box, overwriting whatever was next to it. Best case scenario, your program crashes. Worst case, you've just created a security hole that an attacker could use. So all of this, it really brings us to the core mindset you have to have as a C programmer. It's all about this trade-off between having absolute control and taking on absolute responsibility.
At the end of the day, it's this simple. C gives you the keys to the hardware. It gives you performance and control that other languages can only dream of. But with those keys comes a huge burden. You, the programmer, are the only thing standing between your program and memory chaos. You have to be the one checking the sizes and making sure everything fits.
Which leads us to one last really big question. If C strings are this risky, if they're this complex, then why are they still the absolute bedrock of so much of our software? I mean, from your computer's operating system to the code running in your car, C is everywhere. The answer is that timeless trade-off. For those jobs that demand raw speed and direct control, the power that C gives you is just unbeatable. And learning to master its tools and its risks, well, that's what makes a great programmer.